When you see a rational equation like number 3 that has fraction equals something plus or minus a fraction, there's addition or subtraction with the fractions. You can't use cross multiplication unless you have fraction equals fraction. So we could take the right side of this equation, get common denominators, combine this into one fraction, and then we could cross multiply. But that would be a lot of extra work. So instead, we're going to do a shortcut that involves killing the fractions. Do you guys like that idea? Okay, not quite like that so much, but yeah. We're going to start by rewriting this problem nice and spaced out, and if there's anything that we need to factor, we would factor it as we go. X plus 3, that's as simple as it gets. So I have 2x over x plus 3. Leave a space equals 1. Leave a space. It says minus 6 over x plus 3. Anytime you see subtraction, I want you to change it to plus a negative. Change this to plus a negative 6 over x plus 3. By changing that to addition, you'll get the negative sign stuck onto the next numerator, and that will make everything after that easier. Okay. Kind of stepping away from this example. If I had x plus 2 equals 3, what does x equal? 1. 1 plus 2 is 3. If I multiplied every single term in this equation by 2, I would have 2x plus 4 equals 6. My answer is still 1. 2 times 1 is 2. 2 plus 4 is 6. So by multiplying everything in an equation by the same thing, you don't change the outcome of the equation. You just change how the equation looks. That is the strategy that we are going to use with this equation. We're going to multiply every single term by the same thing, and it's going to basically get rid of all of our fractions. What denominator do you see in this example? X plus 3. I'm going to multiply everything by x plus 3. We aren't trying to get common denominators, so we aren't multiplying top and bottom. We're just going to multiply every term in this equation by the same thing, x plus 3. In the first fraction, notice that the x plus 3 will cancel out the x plus 3, and we're left with 2x. Then we have an equal sign. This next term is not a fraction, so we have to distribute. 1 times x is x. 1 times 3 is 3. In the next term, the x plus 3's cancel, and we're left with plus a negative 6. Is this an equation that you feel like you can solve? Let's combine like terms. Positive 3 and negative 6 is negative 3. Subtract x on both sides, and we get x equals negative 3. By canceling out our fractions, we're left with an equation that is much easier to solve, and we get our solution of x equals negative 3. Now, do you notice in the directions this suggestion right here? Check the answer. We do need to make sure that our solution doesn't create a denominator of 0. What happens if I plug negative 3 into that first x on the bottom? Negative 3 plus 3 is 0. We can't have a denominator of 0, so that solution doesn't actually work. If our only solution doesn't actually work, then what is our answer? No solutions. Now in number 3, we didn't have to do any factoring. In number 4, there is some factoring that we need to do. It will save you a lot of work if you factor before you do anything else. So I'm going to space this out and factor anything that I can see. 3x minus 2, 3x and 2 don't have anything in common, so that's good. X minus 2 is as simple as it gets. Leave a space equals 6 over, can I factor x squared minus 4? It factors into x plus 2, x minus 2. Leave a space, plus 1. Okay, what denominators do you see in this equation? X minus 2 and x plus 2. Now there are two x minus 2's. It doesn't matter if you have two of them. You only want to multiply by one of them. So I like to think of it as how many distinct denominators do you have? You've got an x plus 2 somewhere in there. You've got an x minus 2 somewhere in there. So I'm going to multiply everything by x plus 2, x minus 2. Do you start to see why I suggested that you leave space between each term? Okay. You ready to destroy the fractions? In our first term, the x minus 2 will cancel, and you're left with 3x minus 2 times x plus 2. In our next step, we will have to double distribute or FOIL that. After the equal sign, what is going to cancel? X plus 2 cancels. X minus 2 cancels. What are we left with? 6. In the last one, if this was any other number, I would recommend that you distribute it into the first set of parentheses at least. But if we distribute the 1, it's not going to change anything. So we have x plus 2, x minus 2. Okay, I'd like you to pause the video now and on your own, double distribute on the left, double distribute on the right, combine your like terms and see if you can figure out what we might need to do next. Once you get to a place where you're stuck, then replay the video. Once you have your like terms combined after foiling, just double distributing, all that jazz, you do want to get one side equal to 0, so we'll subtract x squared on both sides. We'll also subtract 2 on both sides. So we have 2x squared plus 4x minus 6 equals 0. Does anyone see any challenges to factoring this one?
No.
The 2 in front. But are all three terms even?
Yes.
Yes. So we can divide everything by 2 to make it easier to factor. So x squared plus 2x minus 3 equals 0. That factor of 2 is not going to change what your answer is. It's kind of like you can multiply every term by something, you can divide every term by something. So now we're looking for two numbers that multiply to give us negative 3 and add up to 2. It has to be 1 and 3. Which one needs to be negative? The 1 needs to be negative. So x minus 1 times x plus 3 equals 0. What are our solutions to this factored function? X equals 1, x equals negative 3. Before you box these in as your final answers, we do need to check these answers back in the original problem. And remember, with rational equations, you're really looking for, do my denominators equal 0? So if you try 1 minus 2, that's not 0. 1 squared minus 4, that's not 0, so 1 is good. Negative 3 minus 2, negative 3 squared minus 4, both of those would not be 0, so negative 3 is good. Our solutions are positive 1 and -3.